Okay, so today we are going to talk about MCP server, and we are going to build MCP server, and we are going to connect it to the backend SQL Server database, and then we will see how we can query it using uh, Cloud Desktop, uh, and it will answer our questions. Like for example, here right now I have already built the server, and the way it's going to work is right now. Let's say if I ask the questions like which tools are available to you, it will list all the tools that is available, and AdventureWorks, it has listed in the default tools. Here it is AdventureWorks. So right now it's able to find out that AdventureWorks is available, and then if I ask like list tables in AdventureWorks, it is listing the tables here. Same way if I ask like list of 5 customers by sales. So originally it has right now two tools as we will discuss, uh, and it can discover the tool as well as it can uh, answer the queries. It builds the query and it answers the queries. So all these things we will see today. So first of all, let's get some overview. Like the entire video is going to be like if you are a data science graduate and if you are learning about AI engineering and how to build such like tools, and then this is going to be helpful to you. And we are also going to discuss how to answer the questions in the interview and what will help you get the job. Okay, so let's start with an overview.
All right. Hey, everyone, and a huge welcome, especially to all you new data science and AI grads out there. If you're gearing up to land that first big job, you are in exactly the right place. Today, we're breaking down a super important new standard called MCMP. And trust me, it's something companies are building their entire AI strategy around. And you want to stick around, because later, Rajan is going to give us a full hands-on demo to show you exactly how it all works. So, let's dive in. Let's just kick things off with a fundamental question, one that's kind of reshaping the entire industry right now. How do we get an AI, like a large language model, to actually do things? How does it connect to and use all the other apps and tools that we use every day? And to really wrap our heads around the answer, we first have to understand this massive shift that's happening in AI. We're literally watching it evolve, moving away from just analyzing information and toward taking real, actual action. What you're seeing here is the leap from what we can call AI 1.0 to AI 2.0. See, the first wave of AI was amazing at finding patterns in data. But this new model, what we call agentic AI, it's all about a cycle. An AI agent looks at its environment, it makes a plan, it takes an action, and then it sees what happened. It's this continuous loop of doing. And this is a great way to think about the difference. AI 1.0 was all about prediction, finding insights. But AI 2.0, it's about getting things done. It has a goal, it makes its own decisions, and it changes its plan if things go wrong. We're moving from systems that find answers to systems that take action. Okay, so this huge shift to action-oriented, agentic AI brings up a brand new problem, right? A huge one, actually. If an AI agent needs to act, it needs tools. But how in the world does it talk to the thousands of different apps, APIs, and data sources out there? How do you create a common language for all of them? Well, the answer is this incredibly smart and elegant open standard called the Model Context Protocol, or MCP for short. It's basically a standardized way to connect our language models with all the tools and context they need to become true agents. And honestly, the creators of MCP have the perfect analogy for it. They call it the USB-C interface for AI agents. And that's just perfect, isn't it? Think about it. Remember that messy drawer full of different cables for every single device? MCP does for AI what USB-C did for our gadgets. It creates one universal standard to connect anything to everything else. So in this picture, MCP is that crucial bridge. It's the translator. the common language that lets the AI agent actually understand and use its environment, which is really just a fancy way of saying a bunch of tools, like checking the weather, pulling from a database, or shooting off an email. MCP is what makes it all work together seamlessly. Now, I want to be super clear. This is not just some cool idea floating around in the lab. The adoption of MCP has been, well, it's been absolutely explosive across the entire tech world. Let me just show you what I mean. So get this, there are already more than 10,000 active public MCP servers out there. And we're not just talking about little side projects. These are being used by everyone, from individual developers all the way up to Fortune 500 companies. And the developers? They are all in. The official SDKs, the toolkits for building with this stuff, are being downloaded over 97 million times every single month. And that's just for Python and TypeScript. The momentum here is it's undeniable. But here's the real kicker. Just look at who is building on MCP. We're talking the biggest names in the game: AWS, Google Cloud, Microsoft Azure on the infrastructure side, and then GPT-4, Gemini, and Copilot on the AI side. The companies that are literally defining the future are using MCP to do it. And don't think this is some super complex, out-of-reach technology. It's designed to be used. You can see right here in Cloudflare's own documentation, they lay out these really clear, well-supported ways for you to build your own MCP servers, whether it's for something simple or something really complex. The path is already there. Okay, so we've talked about the tech, we've talked about the insane adoption, but what does this all actually mean for you, for your career? This is where it gets really important, especially if you're about to start that job hunt. Look, in a job market this competitive, just saying you know about AI models, it's not enough anymore. It's the bare minimum. But when you can walk into an interview and talk about the fundamental protocols that make it all work, when you have hands-on experience building agentic workflows and can say you've created MCP servers, that is a massive differentiator. It shows you're ready to build the future, not just follow trends. So here's the bottom line. Mastering MCP isn't just about learning another piece of technology. It's about proving you understand the architectural foundation of this next wave of AI. You're positioning yourself right at the heart of where all the biggest companies are placing their biggest bets. The agentic future is being built right now on this standard. The only question left is, are you going to be one of the builders?
Okay, so now let us see the demo how we actually build this thing. So let's start with the SQL. So first of all, we talked about like how the MCP server is going to talk with the backend database. So when it talks with the backend database, it's going to need like a login, like it has to be some user. So we have created here user named MCP reader. So and this reader is going to be having the permission to read only, and it's going to um, connect with the AdventureWorks and use it to query it. So this is the code for that. We are creating the user login here. And these are all the permissions that we have granted. Select on this schema and for the permissioning so it can query it. So this is one thing. The another thing is we need to make change into cloud desktop uh, config file. So that file will look like this. Here we have to list all the MCP servers. So in our case, we have the AdventureWorks. This is the name of our MCP server, and we are just saying that command. This is the Python is from here from our virtual environment. Argument is this is our MCP server. Okay. So now the MCP server is this is our MCP server. So to talk about the MCP server, to understand it, let's understand it first in the plain English, like what we are doing here, right? So as we talked before, right, it sits between the end user and the backend database. All right. So it's a translator between the MCP protocol and the SQL Server. So the libraries, one is the MCP, this is from Anthropic. PyMSQL, this will connect to the SQL Server. Async.io, this is to handle multiple connections. So these are a few important ones that we are importing it here. Then we are getting the server, AdventureWorks, this is the name we will give. Then we will define the available tools. So in our case, we are defining two available tools. One is the tables, another is the query tool. So the table tools doesn't have any parameter requirement. It will just list the tools, list the available tables. And the query tool is going to be executing the query on AdventureWorks. Okay, so now another thing is handling the tool calls. So how do we handle it when it's actually calling? The first thing is that Cloud Desktop is going to try to discover the tools, right? Which tools to use, which tools can do what, and that is based on the description that we have here, right? When it has to execute the query, it will know that there is a query tool here. When it just has to list the tables, it will know that to call the tables. So the way it works is, here we have it will be more clear in the code, but okay, so here whatever we have, let us talk about this one. So to connecting to the SQL Server, we will be using the user. This is our user, this is our password, database, this is our server. So all these things we are giving it here. Okay, so now let's talk a little bit into the code. So when we go to the code, we see here that all the libraries are imported, the server is created, then we are testing the connection, then listing the tools here. So here you will see that this is a query, this is the description, and this is tables description. So this is for discovery phase, right? To list the tools, this tool to use when. So but here when we are calling actually, so what I have done is I have in here for the tables, I have hard-coded the SQL. This is so that it will actually know the table schema, tables available, so that it can build the query, how to build the query. So when it is time to build the query, it can use this information and build the query. Here there is no hard-coded SQL, so you understand that this is all the SQL will be built by the Cloud Desktop, by the Cloud AI. Okay, it will translate the English into that SQL and talk with our server using MCP JSON. MCP, then our server will talk to the backend, get the data, again convert it into MCP JSON, send it back to the AI, Cloudy. Cloudy will again convert it to English and return it to us. So this is how the entire flow will work. Okay, and this here we are a little bit of formatting we are doing, using header and all that thing, and some error handling. So this is the entire code on this one. Right now we are running this server here in the virtual environment, and we are seeing when we connect using Cloudy, we see the we'll see the queries answered. So let's say if we ask the question something like let us see what happens. We are saying delete all customers. Okay, now see, this is the perfect answer. I cannot do that. The database tool only supports select queries, no delete update block. So because we have given only select permission, right? So and this kind of tools you might have to build when you are like if you are working as an AI engineer, then you might have this kind of requirements that build something, this kind of tools to connect to the backend databases. You might have like instead of SQL Server, it could be PostgreSQL or Oracle or many other databases you can connect with, right? And the users will have this from their AI, any AI client tool they are using. They can connect. They can the tool can use a server that you have built, and for using that tools, it can answer the user queries. So yeah, now let's talk about the what they can ask you in the interview and how you can answer the questions and get the job. That's the main thing why we are learning all this.
Welcome back to the deep dive. I want to start today by telling you about a thread I was reading this morning. It was in one of the big computer science subreddits, and honestly, it was pretty brutal to read.
Yeah, I think I know the one you're talking about, the reality check for the new grads.
Exactly.
Yeah.
You just have thread after thread of people who graduated in 2024, 2025, saying things like, I have a 3.8 GPA, I spent 4 years grinding leak code, I know Python inside and out, and I can't even get a screening call.
It's rough.
And then you scroll down to the comments, and the senior engineers are replying with this really cold, hard truth. They're basically saying, yeah, because the junior developer role, that guy we used to hand a spec to and say, write the boilerplate, that job is gone. Claude took it.
It is harsh, but there is just a massive amount of truth to it. I mean, we are living through a pivot point right now. If your entire value proposition as a new graduate is, I can write syntax or I can debug a simple while loop, you are competing directly with a model that costs literal pennies per million tokens. It never sleeps. And frankly, it makes fewer syntax errors than you do. The function of the junior dev has been totally commoditized.
And that is exactly the terror we need to address today.
Yeah.
Because if you are just graduating right now, or maybe you're pivoting your career into tech, you're probably looking at this landscape thinking, what is the point? If the AI is already smarter than me, why am I even here?
Well, you're here because the AI is not actually smarter than you in the way that matters for a business. I mean, it's faster, sure. It has way more raw encyclopedic knowledge, but it has a fatal flaw, a flaw that has honestly plagued artificial intelligence since the 1950s. And if you understand this flaw, and more importantly, if you know how to fix it, you instantly become the most valuable person in the room.
We're talking about the brain in a jar problem.
Exactly. The brain in a jar. We have built these completely alien intelligences, right? GPT-4, Claude Opus, Gemini, DeepSeek. They are incredible. They can write poetry, they can solve quantum physics equations, but they are trapped. They're just floating in a void. They can't actually touch anything. They can't check your specific company email. They can't update your Jira ticket. They can't query your production database without you holding their hand every single step of the way.
And that is where the opportunity lies. The tech industry right now is absolutely desperate for engineers who can build the nervous system, the people who can connect that isolated brain to the hands and eyes of a real business.
Precisely. And that is why we are dedicating this entire deep dive to one specific acronym. If you are a graduate or even a senior engineer looking to stay relevant for the next decade, you need to deeply understand this. We are talking about MCP, the Model Context Protocol.
The USB-C of AI.
That is the perfect analogy, and we're going to stick with it today. We're going to trace how we got here, all the way from the logic bots of the 50s to the transformers of today, and explain why mastering MCP is the single best career move you can make right now.
And we aren't just going to talk theory either. We are going to walk through exactly how to build a server using Cloudflare workers and durable objects.
Absolutely.
So grab your coffee, pretend we are sitting in the break room at a major tech company, and the principal architect is finally pulling back the curtain on how the system actually works. Let's just dive right in.
Let's do it.
To really understand why MCP is such a massive breakthrough, I think we have to respect the history. We have a paper here in our source stack. It's titled simply AI Progress. It breaks down the evolution of AI into these distinct generations, and when you read it, you realize that we have been banging our heads against this exact same wall for 70 years.
We have. We failed repeatedly. If you look at the first era, what that paper calls symbolic AI, which spans from the 1950s to the late 80s, the mindset was just completely different from today. The smartest people in the world genuinely believed that intelligence was just a matter of writing down the right rules.
This was the era of the logic theorist and the general problem solver, right?
Right. The operating hypothesis was, if I can just program the rules of chemistry, or the rules of medical diagnosis, or the rules of English grammar, the machine will be intelligent. We called them expert systems. The most famous example, which is cited heavily in the literature, was MYCIN back in the 1970s.
MYCN was the digital doctor, right?
Essentially, yeah. It was designed at Stanford to diagnose blood infections. You would feed it a patient's symptoms, and it would run through this massive, sprawling tree of if-then logic statements. If fever is high and D, white blood cell count is low, then check for X. And here's the kicker. Statistically, on the specific cases it was designed for, it actually outperformed junior human doctors.
Wow. So why do we use it anymore? Like, why isn't there a MYCIN terminal in every hospital in the world right now?
Because of brittleness. That is the key word you have to remember for this entire era. Symbolic AI was incredibly brittle. It worked perfectly inside the tiny, rigid box of rules you wrote for it, but the real world is messy.
Yeah, the real world doesn't follow clean if-then statements.
Exactly. If a patient had a weird overlapping symptom that wasn't hard-coded in the LISP code, or if there was a simple typo in the data entry, the system didn't just make a slight mistake, it completely crashed. It had zero common sense. It didn't actually know what a patient was. It just processed symbols.
It couldn't degrade gracefully. It was all or absolutely nothing.
Right. And when the government and military investors realized that these systems couldn't handle the messiness of the real world, the funding just totally dried up. That is what gave us the famous AI winters.
So the industry pivoted. We went from AI 1.0, or symbolic AI, to AI 2.0, the era of information AI and machine learning. This is the 90s through the 2010s.
This was the connectionist shift, the fundamental philosophy change. We stopped trying to tell a computer exactly how to think. We stopped writing the specific rules. Instead, we started giving it massive amounts of data and basically said, here are 1 million pictures of cats and 1 million pictures of dogs. You figure out the mathematical difference.
Neural networks.
Right. But here's a nuance that often gets missed in CS history classes. Neural networks were actually invented in the 1950s. They called them perceptrons, but they didn't really work back then. They were essentially useless for complex problems.
So what changed? Why did they suddenly take over the entire world in 2012?
The AlexNet moment. It's almost impossible to overstate how important 2012 was. It was the ImageNet competition. Before 2012, computers were just terrible at recognizing images. The error rates were huge. But AlexNet combined 3 specific things that had never collided before.
Okay, walk us through the Trinity.
First, data. The internet had finally matured. We had ImageNet, which was millions of labeled photos. We finally had the textbook needed to teach the machine. Second, the algorithm. Specifically, convolutional neural networks, or CNNs. These were designed to look at images the way a human eye does, identifying edges, then combining those into shapes, then into objects.
And the third piece.
Compute. Specifically GPUs, NVIDIA graphics cards. It turned out, by pure luck honestly, that the math required to render a dynamic lighting shadow in a video game like Call of Duty, which is massive parallel matrix multiplication, is the exact same math you need to train a neural network. When you put those 3 together, data, algorithms, and compute, the error rates didn't just go down, they plummeted overnight.
But, and here's the massive catch for the listener, even though these systems were profoundly better, they were still passive.
Correct. AI 1.0 and even early AI 2.0 was all about classifiers. It was, look at this image and tell me if it's a hot dog. Look at this credit card transaction and tell me if it's fraud. It was identifying patterns, it wasn't reasoning, and it certainly wasn't creating anything new.
Which brings us to the modern era, the generative explosion. The AI progress paper we're looking at points to 2017 as the year absolutely everything changed.
Attention is all you need.
The legendary paper from Google Brain that introduced the transformer architecture. Now, we hear this term transformer all the time now, but let's pop the hood for a second. What did this actually change? Because we definitely had language models before 2017.
We did. We had recurrent neural networks, or RNNs and LSTMs, But they had a massive architectural flaw. They read text sequentially, left to right, just like a human reads a sentence slowly. The cat sat on the mat.
Right.
The problem is, if the sentence or the document is really long, by the time the RNN gets to the end, it has mathematically forgotten the beginning. Its hidden state gets diluted. It had terrible short-term memory. It couldn't handle long-range dependencies at all.
So if I wrote a paragraph starting with Alice held the ball, and then 10 sentences later asked, who has the ball? And RNN would struggle to connect those 2 points.
Exactly. It loses the signal and the noise. The transformer changed the game because of the self-attention mechanism. It doesn't read left to right. It looks at the entire sequence of data at once.
Parallel processing again.
Yes. But more importantly, it calculates the relationship between every single word and every other word in the text simultaneously. It assigns a mathematical weight to those relationships. So when it sees the word bank, it looks at the surrounding context. If the other words are river and water, the attention mechanism knows bank means land. If the other words are money and deposit, it knows bank means a financial institution. It actually understands context.
And that architectural shift is what unlocked the scaling loss.
Precisely. Once we had an architecture that could handle deep context and didn't bottleneck on sequential processing, we could just make them bigger. We threw massive GPU clusters at them. We went from millions of parameters to billions and eventually trillions. And that is when the real magic happened. Emergent abilities.
Explain emergent abilities for the fresh grad who maybe only knows the basics of ML.
It's when a system learns to do things it was never explicitly trained to do just by virtue of its massive size and the sheer amount of data it has consumed. We didn't explicitly program GPT-3 to write Python code. We just fed it the internet. The internet happens to contain all of GitHub. It read the code, it learned the deep syntactic patterns, and suddenly it could code. We didn't teach it to translate French to English. It just learned the mapping in its latent space.
Now we have the frontier models. We have Llama 3, Claude 3.5, Gemini 1.5. And I want to mention DeepSeek here,
Right.
because the AI progress paper highlights it as a prototype for AI 4.0 or conscious AI.
DeepSeek is fascinating because it represents a shift from pure pattern matching to actual reasoning. If you use their R1 model, it doesn't just instantly spit out an answer based on statistical likelihood. It shows its chain of thought. It says, okay, the user asked this. Let me think about the underlying implications. Let me double check my logic here. Let me verify if this constraint holds. Okay, now I will format the answer.
It's moving from system 1 thinking, which is fast and instinctual, to system 2 thinking, which is slow and logical.
Exactly. It's a huge leap. But here is the massive, unavoidable but-ass. Even with DeepSeek, even with Claude Opus, even with the smartest, most capable reasoning models on the planet, we are still completely stuck with the brain in a jar problem.
Let's define this tension clearly, because this specific pain point is what creates the massive job opening for our listeners.
Oh, we have these godlike digital intelligences. You can literally ask them to explain string theory to a 5-year-old or write a sonnet about a broken toaster, and they do it flawlessly. But ask them to check my last 5 emails from Sarah and update her account in the CRM, and they completely fall apart.
Because they don't have access.
Right. Your company's data, the Salesforce CRM, the Postgres database, the internal Notion wiki, it is all behind a wall. It is behind authentication and firewalls. It is private. The AI is trapped in its pre-training data. It knows everything about the world up to its training cutoff date, but it knows absolutely nothing about you. It knows nothing about your specific business context.
So the industry scrambled to fix this. First, we got prompt engineering.
Which, let's be honest, is just a manual Band-Aid. You copy-paste the email text into the ChatGPT web interface and type, summarize this. That works for one single email. It doesn't scale to 1 million customer records.
Then we got RAG, Retrieval Augmented Generation.
A much better Band-Aid, but still a Band-Aid. RAG is essentially a vector search engine bolted onto the AI. You type a query, a script searches your document database for semantically relevant text chunks, pastes those chunks into the hidden system prompt behind the scenes, and tells the AI, answer the user using only this provided text. It works incredibly well for knowledge retrieval, like, what is our corporate vacation policy? Our RAG handles that beautifully.
But our RAG is strictly read-only.
Exactly.
Yeah.
That is the critical distinction every engineer needs to understand. RAG allows the AI to see, but it does not allow the AI to act. It can't execute a Python script. It can't drop a table in the database. It can't send a Slack message to the DevOps channel.
And that lack of agency brings us to the integration nightmare, the M times N problem.
This is the operational hell that every single tech company was living in until very recently. It's described perfectly in the InfoWorld article we reviewed on using MCP in Azure.
Paint the picture for us. What does this nightmare actually look like?
Imagine you are the CTO of a mid-sized tech company right now. You want to deeply integrate AI to automate your internal workflows. You have 5 different AI tools you might want to use, maybe ChatGPT for the marketing team, Claude for the engineering team, Gemini for data analysis. That is 5 clients.
Okay, 5 clients.
Now look at your data sources. Your company uses Google Drive for docs, Slack for communication, GitHub for code, Postgres for user data, and Jira for ticketing. That is 5 sources.
So if I want ChatGPT to be able to talk to Slack,
You have to write a custom bespoke connector. You have to read the Slack API documentation, handle the specific OAuth 2.0 token refresh flow, parse the custom JSON payload, and then format it exactly how OpenAI's API expects it.
and if I want Claude to talk to that same Slack workspace,
You have to do it all over again from scratch because Anthropic's API expects a totally different format than OpenAI's.
and what happens if Slack updates their API endpoints next month?
Both of your custom connectors instantly break. You have to maintain 25 different custom integration bridges. It is pure spaghetti code. It is brittle, it is unmaintainable, and it is the exact reason why, until recently, most AI agents were just fancy conference demos that broke the moment you put them in a real production environment.
Because companies don't actually want a chatbot. They want a digital employee. They want an agent that can say, I see you have a meeting with the enterprise client in an hour. I pulled their latest usage figures from the Postgres database. I summarized their last 3 support tickets from Jira, and I updated the Salesforce entry so you're ready to go.
Exactly. They want action. They want agency. And to get scalable agency, you need a standard interface. You have to stop building custom bridges for every permutation and start building standard ports. Enter MCP,
The Model Context Protocol.
the USB-C port for the AI age.
I really love this analogy because literally everyone remembers the absolute nightmare of cables before USB-C became the standard. You had a proprietary charger for your phone, your camera, your laptop, your wireless mouse.
And now you have one single cable. If you manufacture a hard drive with a USB-C port today, you don't have to write separate low-level drivers for a Mac, a Windows PC, an iPad, and an Android phone. You just build the standard port to the spec, and anything can plug into it. MCP is that universal port for machine intelligence.
So mechanically, how does it solve the M times N problem?
Instead of building a custom connector for every single AI model, you build an MCP server for your data source exactly once. You build a Slack MCP server. That server speaks the universal open source language of MCP. Now, Claude Desktop can plug into it, ChatGPT can plug into it, the Cursor code editor can plug into it. Literally any AI host application that speaks the MCP language can suddenly interact with your Slack workspace.
That completely transforms the engineering workload. Instead of maintaining 25 fragile bridges, you build 5 robust ports.
And the ecosystem just explodes because of it. Because now, as a platform developer, I don't have to worry about which foundational model my company decides to use next quarter. Maybe we switch from GPT-4o to Claude 3.5 Sonnet because the coding benchmarks get better. If I use the old spaghetti code way, I'd have to rewrite all my internal integration code. With MCP, I just switch the host application. The server infrastructure I built stays exactly the same.
That is huge. That is actual scalable infrastructure grade thinking.
It is the industrialization of AI. We are finally moving from the hobbyist phase where we just duct-taped API calls together in Python scripts to the industrial phase where we have rigorous standards and protocols.
Okay, let's really get into the weeds here. I want to understand how this actually works on a technical level. We have the official Model Context Protocol specification right here. What is actually happening under the hood when a connection is made?
At its core, the protocol is based on JSON RPC 2.0 messages. It's a classic client-server architecture, but it's been heavily adapted for the unique lifecycle and needs of large language models. There are 3 main roles in the architecture that you need to deeply understand.
Okay, give us role number 1.
The host. This is the client in traditional networking terms, but the spec calls it the host because it is the application that is hosting the AI model. Think of the Claude desktop app or the Cursor IDE or a custom internal dashboard you build. This is the brain that is initiating the request for context or action.
Role number 2.
The server. This is what you, the listener, are going to be building. This sits directly on top of your proprietary data or your internal tool. It acts as the adapter. It translates the AI's standardized request into whatever proprietary API calls your database or SaaS platform actually understands. The server is completely agnostic. It has no idea if it's talking to Claude or Gemini. It just knows I am authorized to serve these specific capabilities.
And rule number 3, which might be the most important for security.
The user, the human in the loop. The architectural spec is very, very specific about this. The user must always be in control. Because if you give an autonomous AI literal hands to execute commands, you really do not want it dropping your production database because it hallucinated a SQL command during a chaotic reasoning loop. The host application is responsible for managing the permissions and prompting the user. Like, do you want to allow this server to run this specific tool?
Yeah, let's talk about those capabilities.
Yeah.
What can an MCP server actually do? The spec lists 3 distinct primitives that a server can expose to a host. Let's break these down for the grads.
Right. The first primitive is resources. This is passive, read-only data. Think of it like exposing a virtual file system to the model. Here is a server log file. Here is a specific row in a Postgres database. Here is a rendered screenshot of a web page. The AI can read this data to gain context, but it absolutely cannot change it. It's like handing the AI a reference book to read before it answers. This basically replaces the really messy part of RAG pipelines where you have to manually chunk, embed, and index everything into a vector database. The AI just dynamically asks for the resource URI it needs.
Okay, so that's the read-only layer. What's the second primitive?
Prompts. This one is surprisingly often overlooked, but it's incredibly powerful for enterprise teams. These are essentially templated instructions hosted on the server. Imagine you are a senior DevOps engineer and you have a very specific, rigorous way you want incident postmortems to be formatted. You want the timeline, the root cause analysis, the resolution steps, and the action items formatted in Markdown. You can save that exact template as a prompt primitive inside your MCP server.
So when a junior engineer asks the AI, help me write the postmortem for the Redis outage, the AI pulls that authoritative template directly from the server.
Exactly. It standardizes workflows across an entire organization. Instead of every individual engineer writing their own slightly different prompt to the AI, or keeping a messy text file of useful prompts on their desktop, the entire team shares a set of gold standard prompts served dynamically via the MCP infrastructure.
And the third primitive, because this is the one that gives the AI agency.
Tools. This is where the actual magic happens.
Yeah.
A tool is an executable function. Run this complex SQL query, send this drafted Slack message to the marketing channel, restart this specific Kubernetes pod. This is the hands of the AI.
So the host, let's say it's Claude, connects and sees a manifest of tools provided by the server. It analyzes the user's request and says, hey, I need to execute this specific tool with these specific JSON arguments.
Yes. And here is the truly genius part of the protocol design. We have a source here, Anthropic Upgrade's open source MCP, that explicitly talks about a massive architectural upgrade called MCP Tool Search and the concept of lazy loading.
Why is lazy loading so critical for AI specifically?
You have to think about the context window, the short-term memory of the AI model. It is strictly limited in size, and every single token costs money and compute time. The old, naive way of doing agentic workflows was pure brute force. We would take every single possible tool definition your company had, literally hundreds of them, and stuff them all into the hidden system prompt on every single API call. We'd basically say, here is every tool in the entire company, read them all, and good luck figuring out which one to use.
That sounds incredibly expensive and honestly really confusing for the model's attention mechanism.
It was. It consumes massive amounts of input tokens, it drastically slows down the time to first token inference speed, and it actively confuses the model. It's like walking into a massive commercial kitchen and dumping every single utensil, pot, and pan you own onto the counter before you even decide what recipe you're going to cook. The AI just gets overwhelmed by the noise.
So what does the new MCP tool search architecture do differently?
It allows for true dynamic lazy loading. The AI connects to the MCP server, but it does not load all the tool schemas into its context window immediately. Instead, it can search the server for what it needs. It says the user wants to check the latency metrics for the European servers. Hey, MCP server, do I have a tool related to latency or Datadog? The server searches its available tools, finds the relevant one, and only then does it load that specific tool definition into the AI's context window.
That is just proper, elegant software engineering applied to AI. It's runtime optimization instead of brute force.
It changes everything. It means an enterprise can have an ecosystem of thousands of specialized tools across Jira, Trello, Slack, Salesforce, internal APIs, all available on standby, but you only ever pay the token cost for the tools you are actively using in that exact moment.
Yeah, and the option numbers we're seeing prove that the industry agrees this is the way forward. The Anthropic blog post mentions there are already over 10,000 active public servers out there. And get this, over 97 million monthly SDK downloads.
97 million, that is not a cute niche experiment. That is enterprise industry standard territory. If you are an engineer ignoring this protocol right now, you are ignoring the exact way the internet is being fundamentally replumbed for the AI age.
Okay, so I think we have firmly established that MCP is the future. Now I want to pivot to the practical application. I want to talk directly to the graduates, the career switchers, the people listening to this who want to actually get hired. How do you actually do this? We have an excellent technical guide from Cloudflare here titled Build a Remote MCP Server.
This is exactly where we bridge the gap between just knowing about AI and actually being an AI engineer.
The huge challenge right now in the job market is that most CS grads know Python. They know how to write a basic REST API. Most data science grads know how to run a Jupyter notebook and maybe fine-tune a Hugging Face model.
But very, very few of them know how to build the actual integration infrastructure. If you walk into a technical interview today and say, oh, I can fine-tune a Llama 3 model, the hiring manager might just shrug and say, cool, but we just use the OpenAI API because it's cheaper and faster. But if you sit down and say, I built a custom MCP server that securely connects your legacy on-premise SQL database directly to Claude so your non-technical sales team can query revenue data in natural language.
You are hired.
Immediately.
Instantly. You skipped the junior dev queue entirely because you were solving a massive, expensive business problem.
So let's walk the listener through the hello world of modern AI engineering. We aren't just going to run a simple script locally. We want to build a remote MCP server. Why is the remote part so important? Because a local server running on your laptop only works for you. If you close your laptop, the agent loses its connection and dies. A remote server lives in the cloud. It means your entire engineering team can connect to it. It means you could actually build a scalable product on top of it.
And the Cloudflare documentation heavily suggests using Cloudflare workers for this. Why workers? Why not just spin up an AWS Lambda function or deploy a Docker container to ECS?
It comes down to speed, cold starts, and architectural simplicity. Cloudflare workers are built on V8 isolates. Unlike a traditional Docker container that has to boot up an entire virtualized operating system, load Node.js, and then run your code, an isolate just spins up a tiny, secure JavaScript environment within an existing process. It boots in literal milliseconds. It completely eliminates the cold start problem. It's entirely serverless. You just write your TypeScript code, deploy it to the global edge network, and it runs within milliseconds of your users everywhere on Earth. It is genuinely the perfect, lightweight, low-latency home for an MCP server.
The Cloudflare guide gives us two distinct architectural options for building this. Option A uses the create McFeanler function.
This is the simple, straightforward path. It creates a stateless server. Imagine you're building a calculator tool for the AI, or a tool that fetches the current weather for a city. The AI asks a question, the server processes it, returns the answer, and immediately forgets that you ever existed. It does not need to maintain any conversational history or state between requests.
Perfect for simple utility lookups.
Exactly. One of the open source examples in the GitHub repository we looked at, I think it was Jamatia's 2411's repo, is called Bitcoin MCP. It literally just fetches the current real-time price of Bitcoin in USD. That is a perfect use case for a stateless tool. Claude asks, what's the price? The server hits the CoinGecko API, returns $95,000, and cleanly terminates the connection.
But what if I want to build something much smarter?
Yeah.
What if I want an agent that actually remembers what we were talking about 5 minutes ago? Or an agent that needs to keep a running tally of a user's budget across multiple back and forth prompts?
Then you graduate to option B. You build a McPagent using Cloudflare's durable objects.
Durable objects. I hear this term a lot, and it sounds a bit like marketing speak. What is it technically under the hood?
It is arguably one of the most powerful pieces of stateful tech deployed right now. Normally, serverless functions are completely ephemeral. They spin up, run, and die. They have total amnesia. Durable objects fundamentally change that paradigm. A durable object is a globally unique instance of a class that stays alive. It tightly couples the compute, and the storage in the exact same location.
So it's essentially like a dedicated microserver just for that one specific user's conversation.
That's exactly how you should think about it. It's a tiny, single-threaded server instance that has its own persistent, private, in-memory storage. And because it is strictly single-threaded by design, you don't have to worry about complex race conditions or distributed locking when updating variables. You can just write this, .storage, .put, destination, Paris, in your JavaScript. And it saves it. It persists across invocations.
So if I'm building an AI travel agent and I tell Claude, I want to go to Paris next month, and then we talk about flights for 5 minutes, and then I say, actually find me a hotel near the center.
Yeah.
The durable object still perfectly knows I'm talking about Paris without me having to restate the context.
Yes, it maintains the state natively. If you are building a complex multi-step agent, essentially a brain that requires reliable memory, you need durable objects. It simplifies the backend architecture massively. You don't need to spin up and maintain a separate Redis caching cluster or a complex Postgres database just to remember a chat history. It's all handled natively within the object itself.
Okay, so step 1 for the listener. Pick your complexity. Stateless for utilities, stateful with durable objects for complex agents. Step 2 is writing the tool logic, and step 3, which might be the most critical, is security.
This is the senior detail.
Yeah.
This is exactly what separates the bootcamp grads from the enterprise professionals.
The Cloudflare docs make a massive point of this in the tutorial.
Yeah.
You absolutely cannot just deploy your MCP server and leave it wide open to the public internet.
If you build an MCP tool that has the capability to delete a database row or send an email from your domain, and you put that URL on the public internet without a lock on the door, you are going to have a catastrophic day. Automated botnets will find that endpoint in hours. They will blindly exploit it.
So what is the standard solution here?
Authentication. Specifically, implementing an OAuth 2.0 flow. The Cloudflare documentation explicitly walks you through how to integrate standard GitHub or Google login directly into your MCP server flow.
Walk us through the UX of that workflow. How does the AI actually authenticate itself to your custom server?
Okay, so the user, you, opens the host application, let's say Claude Desktop. You go to settings and try to add your custom server URL. Claude reaches out and tries to access your server. Your server receives the request and says, oh, stop, I have no idea who you are. It returns an HTTP 401 unauthorized error and redirects the user's browser to an OAuth provider, like GitHub.
So I get a pop-up, and I log in with my GitHub credentials on the browser just like any other app.
Right. GitHub securely verifies your credentials and issues an access token. Claude takes that secure token and says, okay, now I have the VIP pass. From then on, every single time Claude asks the server to execute a tool, it automatically includes that bearer token in the authorization header of the JSON RPC request.
And because you have that token, you can scope the permissions, right?
Absolutely. You can implement role-based access control. You can say, this specific user token only has read-only access to the database tools. This other user has full admin access to execute write tools. Listen, if you walk into a system design interview and you can clearly articulate how you handle OAuth scoping for your custom AI agent so that a junior dev couldn't accidentally drop the production tables via a chat prompt, you are demonstrating a level of engineering maturity that 99% of candidates simply do not have yet.
I want to look at a few more real-world examples from that GitHub repo to spark some ideas for the listeners. We mentioned the stateless Bitcoin price checker. What else did people build?
There's a really cool one called Red MCP. This one is brilliant for sysadmins and DevOps teams. It exposes core system utilities to the AI. It allows the model to securely check running Linux processes, tail system logs, and check active disk usage across the cluster.
Oh man, so instead of me having to SSH into 3 different remote servers at 2 a.m. and trying to remember the exact syntax for grep and awk to find an error.
You literally just open your MCP-enabled chat and tell the AI, hey, find all the error logs from the last hour related to the Stripe payment gateway across the production cluster. And the AI uses the Red MCP tools to actively go out, run the commands, parse a raw text output, and give you a clean summary of the failure.
That perfectly illustrates the power of giving the AI hands.
Yeah.
You aren't just asking it to write the bash script for you to run manually. You are giving it the secure tools to debug the infrastructure itself.
Exactly. Or look at another simple one from the repo, Climate MCP. It just queries a weather API for real-time local conditions. Sounds trivial, right? But it perfectly proves the fundamental point. The AI model itself does not know the weather. Its training data stopped months ago. It mathematically cannot know if it's currently raining in London. It absolutely requires that external tool integration to be useful in the present moment.
I want to zoom out to the big picture now. The Future Vision, Part 6 of our deep dive. We have a major press release here in the stack titled Donating the Model Context Protocol.
This was a massive strategic bombshell in the industry. Anthropic developed MCP internally, but they recently made the decision to donate the entire protocol to the Linux Foundation, specifically to the newly formed Agentic AI Foundation.
That's a lot of corporate proper nouns. Why does that specific move matter to the average engineer listening to this?
It matters deeply because of trust and standard adoption. Think about it. If MCP was indefinitely owned and controlled solely by Anthropic, then massive competitors like OpenAI, Google, or Meta might hesitate to build native support for it in their tools. They wouldn't want to rely on a direct rival's proprietary standard. They would inevitably build their own competing standards like a GPT-link protocol or something, and we would be right back in the M times N nightmare.
Right, it would be the classic VHS versus Betamax format war all over again.
Exactly. But by legally giving it to the Linux Foundation, which is the exact same neutral governing body that oversees the Linux kernel, Kubernetes, and Node.js, MCP becomes completely neutral territory. It becomes a true, unencumbered, open standard that everyone can trust.
And we immediately saw the heavy hitters line up to support it. The press release mentions AWS, Microsoft, Google, Block, all officially backing the standard.
That's the signal you look for. It's open source. It's vendor neutral. It is here to stay. This isn't just a flash-in-the-pan framework that will be obsolete in 6 months. It is actively becoming the foundational plumbing of the AI-native internet.
And that leads directly into this fascinating InfoWorld article we reviewed about using MCP in Azure. It paints a very vivid picture of what the future role of the AI engineer actually looks like.
This is the core vision I really want the listeners to hold on to. The article details something called the Azure MCP server. It essentially allows an AI model to natively interact with Azure cloud infrastructure via the command line interface.
So in the near future, I might not be manually clicking around in the slow Azure portal GUI, trying to remember where they hid the Create Virtual Machine button in the latest UI update.
No, absolutely not. That web UI is built for humans, and it is inherently slow and error-prone. In the near future, your primary job title will be orchestrator. You will sit down and say to your senior agent, spin up a new, highly available Kubernetes cluster for the Q3 marketing campaign, ensure it uses our standard IAM security protocols, and immediately deploy the latest container build from the GitHub staging branch.
And the agent just handles it.
The agent leverages the Azure MCP server you configured to execute the exact sequence of CLI commands. It monitors the deployment output in real time. If there is a configuration error or a timeout, it doesn't just crash. It reads the specific error log, leverages its reasoning capabilities to fix the YAML configuration, and iteratively tries again until it succeeds.
That drastically changes the day-to-day job description of a software engineer.
It fundamentally changes it. The AI engineer of 2026 or 2027 is not sitting there manually training a neural network from scratch using PyTorch. That specific job is for the research labs. That's for the PhDs at DeepMind and OpenAI. The practical AI engineer is designing the nervous system of the enterprise. You are making the high-level architectural decisions. Which specialized agents do we need? What exact data tools do they need secure access to? How do we implement the OAuth flow to secure those connections? How do we ensure that the data analysis agent can cleanly pass a payload to the marketing agent using the MCP protocols that you built?
You are essentially the architect of the digital swarm.
Exactly. You aren't writing the boilerplate code anymore. You are building the secure, scalable digital ecosystem in which these alien intelligences can actually live, interact, and perform real work for the business.
That is incredibly exciting and honestly, slightly terrifying, but mostly exciting.
It's the best possible kind of terrifying. It means there is actual, tangible work to be done. Real, hard, highly valued engineering work. It means we aren't just going to be prompt jockeys tweaking adjectives in a chat box. We get to be actual builders again. We get to build the infrastructure of the next decade.
So let's wrap this up and summarize the deep dive. We have covered a massive amount of technical and historical ground today.
We really have. We started all the way back with the history lesson. We saw how the industry moved from brittle, hard-coded rules, those expert systems like MYCIN that ultimately failed because the real world was just too messy, into the pattern recognition era of AI 1.0 triggered by AlexNet and GPUs.
Then came the transformer architecture in 2017, the brain. It finally gave machines context, understanding, and those incredible emergent abilities like coding and reasoning. But, as we discussed, it was still fundamentally a brain in a jar, locked away, completely isolated from our private data and our tools.
And that is exactly where we find ourselves right now. The integration gap. The massive M times N nightmare where every single tool requires a custom brittle API bridge. And the elegant solution to that nightmare, MCP. The universal USB-C port that safely and securely connects that massive intelligence to the real world.
And the action item for the listener is crystal clear. The job market right now is absolutely flooded with people who can write a clever prompt. It is flooded with people who can copy-paste a cool script and run a local demo in a Jupyter notebook.
But the enterprise market is desperately starving for people who know how to write robust servers. They need engineers who deeply understand authentication flows, state management, durable objects, and cloud infrastructure.
So here's our final provocation for you to take away. 5 years ago, AI engineer wasn't even really a recognizable job title. Or if it was, it meant you had a PhD in advanced mathematics and you spent your days optimizing loss functions.
Today, that exact role is being rapidly redefined by the people who understand integration. The pragmatic engineers who can securely glue these massive systems together to solve actual business problems.
So don't just sit there chatting with the model. Don't just ask it to write a poem or explain a concept. Give it hands. Give it eyes. Go to the Cloudflare documentation, open up that open source GitHub repo, and build a functioning remote MCP server this weekend.
Connect it to your Spotify account. Connect it to a free weather API. Connect it to a Google spreadsheet. It doesn't matter what it is at first. Just build something that actually connects the digital brain to the physical world. That is your competitive edge. That is exactly how you get hired in this new landscape.
And when you do build it, seriously, send us a message. We would absolutely love to hear what you put together.
Absolutely. Good luck building.
Thanks for joining us on this deep dive. We'll see you next time.